section 11.3. We're going to talk about circles. And actually, what we're going to talk about second is very similar to what we've done before. Anyway, when we get to it, I'll show you what we're talking about.
Today's the 11th, right?
Today is the 11th. That's correct. Which one's a circle? That one right there? Okay. Let's put a circle in here. We mentioned this yesterday, and you guys already told me. And you probably knew this already, what the area of a circle is. What is the area of a circle? It's pi r squared. Okay? A lot of people get confused between the two. We've already talked about something else of a circle. What else did we talk about on the circle? What is the circumference of a circle? It's 2 pi r. Okay, and you can see how easy it would be to get confused. But watch this. 2 pi r. If I multiply those together, I just get, like, the radius would be like in inches, let's say, okay? This would just be in inches, correct? Because 2 doesn't have any dimensions. Pi doesn't have any dimensions. Radius is the only thing, and it's just in inches. So circumference is an actual distance, isn't it? All right, it's just the length of something. So that would be in inches. What about this, though? If the radius was inches, what would we get? We get inches what? Squared. And inches squared is always what? Did I give you enough hint? It's the area, okay? It's the area, all right? So area is always pi r squared. Everybody got that?
Yeah.
So a lot of people get confused, but I think just seeing that squared kind of takes away that confusion. When you see something that's being squared, you know that's area. So really, what are we trying to do here? If I want to find the area of this circle, what am I really trying to do? I'm trying to find out how many what fit inside of this. How many squares? That's right. How many squares fit inside of this? Exactly right. That's why you get decimals so much on circles, because look, if you put little squares in here, let's go to the square tool. If you put little squares in here, right? And if I copied and pasted a whole bunch of squares, let's make this a little bigger so I can grab that thing. Okay. So watch. What if we sat here all day and put a whole bunch of squares in here? It'd be a little bit of a waste of time, but what would happen? Look what happens. You get these little, and that's a little curved area, isn't it? All right, so it's not going to come out even. It's not going to fit perfectly, is it? All right, so that's what you're actually doing, though. You're trying to find how many squares, how many 1 by 1 squares actually fit inside the circle, and that's what you're finding when you find the area of anything, and especially right here. We've talked about pi already, so we don't have to talk about that. So look how easy this would be. What if they give you the radius of the circle? And let's just say the radius is 5. Then how would I find the area? Area is what? It's pi times what? 5. Oops. 5 squared. And that's 25 pi. I had a book. Every time they asked for area, that's the way they want you to leave it. They never even put in the answer key what the decimal approximation was. All right, on this book, they plug it into a calculator and get a decimal, and that's fine. There's no problem with that. But you could, if you wanted to, save you a couple seconds. Or you could just leave it 25 pi for all I care. All right, but when I read off the answers, though, I probably won't read it off as 25 pi. I'll probably read it off as a decimal because that's the way that this particular book writes the answers. Make sense? All right, that was easy. And really, the rest of the lesson's kind of easy, too. Let me get rid of this. What if I wanted to find not the area of the whole entire circle, but what if I wanted to find the area of just a chunk, a piece of the circle, a piece of the pie, or the piece of the pizza pie? What if I wanted to just find the area of this bit right here? That's supposed to be shading, okay? All right, yeah, so if this radius right here, let's just call it 5 again. We used 5 before, let's use it right here. So yeah, that would be 5 as well, but that really is not really going to help you that much. There's something else, though, you'll probably need to know. Probably need to know the angle, okay? And let's just make up some crazy angle. Let's say it's 57 degrees, okay?
Well, they always give you like...
Yeah, it pretty is. That's pretty close to 60, so I said that wouldn't be a bad representation of 57 degrees. All right, so what are we going to do? Now, remember when I said we've kind of done stuff like this a little earlier? Remember the circle chapter, right? It was just last chapter. We found what? The length of that segment, of that arc, didn't we? So how did we find that length? We didn't find the length of the whole entire way around the circle. That would be the whole entire circumference, wouldn't it? So, right, whatever the angle is over 360. This is exactly the same thing. We're just finding a piece of this whole entire circle, aren't we? So how much of the whole circle are we finding? 57 degrees out of what? 360. But this time we're not going 2 pi r. What are we doing? Pi r squared. And the r is 5, so we square it, chuck it in a calculator, and you're done. So isn't that very, very close to what we did before? So if you had that, if you understood that the length of this arc was 57 over 360, 2 pi r, then it's not much of a stretch to figure out how to do this. Yeah. Yep, you'll need to know the radius and the angle, or they may give you some other stuff you got to figure out the angle, okay? It's not always going to be that easy. They're not just going to say, here's the angle, here's the radius, bang, find the area. All right? So you may have to do a little manipulation. You might have to do some things that we've done in the past to be able to find that angle, maybe to find the radius and different stuff like that. But do you get the idea on how to find that? We call this, by the way, they even give this a name. All that shaded part right there is called the sector of the circle. Of a circle. It is. It's a section of it, yeah? It's a section of it. You probably heard about, I don't know, like on, I don't know, I'm thinking of movies or something. He's like, yeah, move them over to sector 13 or something like that. You ever hear that kind of stuff? Okay, that's basically what they're talking about. This section. Go to this section over here. And sometimes they call it sectors, and that's what we call this thing. We call that a sector. S-E-C-T-O-R. Well, that was pretty easy, wasn't it? I'm looking at it, and I'm thinking that's pretty much it. Wow. They do throw a few little twists in there towards the end. Let's... I'm looking for one. That's what I'm doing. I'm looking. They don't really give you the tough ones in the examples. Man, I hate to ruin the fun and give you one of the problems I'm going to give you. All right, we'll do one.
I will. I'll sit there and be like, now what can I do? And I'm just sitting there.
Just sitting there. Okay. Let's do this. Just pretend it's a problem.
Pretend. Can it be a problem?
Um,
Maybe I can like look at it and be like, oh yeah.
You doing? I think you're doing 35.
I think he's gonna do 35 or 70.
Yeah, probably.
do different numbers.
No, that's what I thought you were gonna do.
Yeah, maybe I can do that. That looks pretty good.
Yeah, I don't like 32.
You don't like them?
Yeah, they don't. There are no
Oops.
examples.
I know, that's what I just said. That's
If
why
I could
I
ask you
decided to
please
do one.
dismiss the girls' soccer team at this time, thank you. Also at 2 p.m., if you could dismiss girls' varsity softball. 2 p.m. for softball and dismiss
Goodness
soccer at
gracious.
this time. Thank you.
Alright, you getting the idea? And watch this. Okay, for you guys that are leaving, this is on YouTube. And homeworks, it'll be on there. And yeah, you know the deal. Alright, so everything. Oh, you know what I could do? Watch this. I just thought of this. Watch this. Let's fill it with, what do you want to fill it with? Let's go with pink. Okay, but
Ooh,
watch this.
I like that.
Yeah, right. Fill the circle
my
with
favorite
white.
colors. Oh, ew.
Now that is cool looking, isn't it?
That ruined it.
It ruined
It's
it.
ugly now.
Yeah, don't do the white.
You don't want white? What do I want to? What do you want to fill it?
Black.
Yellow.
Lime green. Yellow.
I think black.
Let's
is
go
fine.
yellow since we've outlined it in yellow.
That looks much prettier.
Okay.
Yeah.
Goodness.
That
Let's do this. Let's make this stroke black, and let's make this stroke black.
That line is
It's
so
that
annoying.
line. There's gone. Does it feel better now? It's because it's a long story. All right. No, it's on the program. All right, don't worry about that. So what do they tell you? They tell you the whole thing. Now I gotta go back to this. they tell you the whole bottom of it is 10, right? And this is 5. And they also, let's find where the center is. It's right there. And let's find the center of this one. It would be right there. And they connect the two. Like that. What, the line? Thicker? Is that better?
I always think around
No,
that.
it's good enough.
I know,
Alright.
it's so annoying. Now I always think of
What are we trying to do? Find the area of the shaded region. That's all they tell us, isn't it? Alright.
the yellow.
So, what do you think?
Pink on there. Yellow.
The pink. The pink is the shaded region, right. Yep. That's why I made this white originally. Because, right. Yeah, but then there's too much black
Find
all
the
around the thing. Pink. We're finding the pink. Alright, so, what do you think?
Oh, no, I know.
Look, what if we drew a radius to here? Alright, go ahead.
Do
Okay.
you have to do, since they give you like the outside, so you have to do the base times the height, which is the 10, like to find the,
Would 5 be the diameter
Yeah.
of the circle?
Wait a minute, let her talk.
like,
Go ahead.
you have to find the area of the
Right.
Triangle or
What is that thing? It's a
the
rectangle.
rectangle, sorry.
Yes, the area of the rectangle.
Yeah. So it's 10 times 5, which is 50.
Right, so basically, let's kind of generalize it first before we get real specific. What are we going to do? We're going to find the area of the rectangle, then do what?
Minus the 2 circles.
Minus the area of the 2 circles. And that's what, and the pink's what's left over, correct? Everybody with me on that?
How do you find the area of two circles?
Okay, well, let's do the rectangle first. That's
We all
easy.
know
It's
how to
50,
do it.
right? So it's 10 times 5, which is 50. So we're going to, now we got to find the circles. Let's just find one, right? And then we just
Yeah,
double it and we
double.
get it. All right, so how do we find the area of
Would
this?
5 be the diameter?
5 would be the diameter, correct? Because look, and that's why I drew this line right here, because if I go from here
Down.
all the way to there,
That's 5.
that would be the diameter, wouldn't it? Well, what is this? This line right here is actually the same as the diameter of that circle, isn't it? So if the diameter is 5,
The radius is 2.
then the radius is 2.5, right? So actually, or you could just do this. Nah, let's not do that. Let's so the radius is what? 2.5. So let's just find the area of it. So the area of the circle is pi 2.5 squared, correct?
But we could just leave it
Two.
like that.
Well, let's 2.5 squared is 6.25. So it's 6.25 pi, correct? That's one circle. Would you agree? What would 2 circles be? 6 and 6 is 12. Quarter and a quarter is a half, so 12 and a half, right? So both circles would be 12 and a half pi. And so not minus 50, because what's bigger?
50 minus
Right, the rectangle's bigger, isn't it? Because the 2 circles fit inside the rectangle. So it's 50, the total. I'll put total. The total area of the shaded region, correct? Would be what? 50 minus 12.5 pi. And you can just chuck that in your calculator. And you could do this several different ways. I mean, you could have made that a decimal right there. But remember, I wait to the end to round things, okay? So if I can work with pi, I'm going to work with pi first. And then at the very end, I'll go ahead and put it into the calculator. Does that make sense? No, because it's not 50 minus 12.5. You have to multiply before you add or subtract, order of operations. Okay, it's a good question. Some people might do that. You can't go 50 minus 12.5 and then multiply that by pi, because this doesn't have a pi, right? So you have to go 50 minus whatever 12.5 pi is.
10.7?
Number 35. Yes, 10.7. 10, and I'll let you do that. I've done everything already for you. So there you go. I mean, that's kind of the idea that you want to have. Okay, a lot of finding the shaded stuff is taking the larger one, taking the smaller things away from it, and that's the kind of stuff that you're going to do. So you have to think a little bit, right, about what the radius is and all that good stuff, right? And this, really, knowing that that was 10, did that really, did you really need that? Well, yeah, you did need that, actually, because you need to find the area. Well, actually, you wouldn't need, the 10. No, you wouldn't. Watch. Because look, if the radius is 2.5,
Oh, then it's 5.
right. See, look. If I extended that all the way to here, and I
it'd be
extended this
5 and
all the way
5,
to
which
here, I
is
wouldn't
10.
even need the 10, right? Because that whole thing's 5, that whole thing's 5, so the whole thing is 10.
But for number 36, you got the radius, and then it's not a triangle because it's like a circle.
Right.
You have the other way to find area, which is like.
Well,
You
you
have
know the whole
vertical-
thing
you
is
have vertical
130
angles.
degrees.
Yeah.
So watch. What would the vertical angle with that 130 be?
130.
That'd be 130. So that's 260, right?
Mhm.
So you take 260
Oh,
away
over
from
36.
360, which would be what?
100.
100. Both of those angles are equal, so they're both 50. Right.
And then you just do the sector.
So you would do 100 over 360.
And you really wouldn't even care that they're both 50. I would just go 100 over 360. Exactly right. Okay? Takes a little thought, and that's a good thing. All right? It's not a bad thing. I know you think it's a bad thing at this time of your life, okay? But it's actually a good thing. It's actually a good thing to have to think a little bit, all right? You need to be challenged a little bit, and that's what this does. How about you just look at them and try them?
It's like a triangle. And
It is a triangle.
A radius. Sorry.
Well, it's inscribed in a semicircle, right? Okay, so what do you know about it? What do you know about it's 40? It's not necessarily 45, but it's what? It's a 90-degree angle. So it's a right triangle, and they give you two sides of the right triangle, right? What's that? No, they give you the 11. They give you the 11. Yeah, they give you the 11 and the 9, right?
33.
I'm looking at 33. Our books have been different from time to time. Maybe it is.
It's just 5 square root of 2.
On
Yeah,
33.
it says 5 square root of 2, yeah.
Wow, mine doesn't say anything close to that. Mine says one side's 11, one side's 9.
See,
Let me
look.
see yours.
How would for this one? How would you know?
Oh, that's right.
How would you
It does
know?
say that, doesn't it?
Yeah. That's like I don't. What would you do? Because
Yeah.
that's a semicircle, but usually you would just do Pythagorean theorem, but you don't have the other two sides, and we know that those two sides aren't equal.
Yeah, because see my book. Look at my book. See, that says 11 and that says 9.
See, look, these are different.
Well, let's do
wait,
this. Let's do 9 and 11. See if it actually comes out to the same
That's the
thing.
same- that's
But
the
it's
same.
weird. Yeah, you're.
Sorry.
I mean, it does that every once in a while. We've seen that before, haven't we?
Yeah.
Where it's done that.
Well, look at the answer in the back of your book. And then look at the
So
answer.
basically, it looks like
What number is it?
this.
33. It says 53.5.
It looks like that. It looks like this, right?
Caitlin, you're in the way.
What? I know. Yeah, his is 55.9, and ours is 53.
So even the answers are different.
Yeah.
Okay. And what is this? 5 squared to 2? Is that what you said?
Yeah.
Well,
And then there's a circle around it.
my guess is, wow. Yeah, I don't think they give you enough information there. Right, and there's a circle around it. I just did this part right here. Well, you got to find the radius, right? That's really what you want to find.
You want to find that line right there.
Because you got to find the area of the circle, correct? So you find the area of the
Well,
circle,
those
take
two are
away the
equal, so
triangle.
you can do Pythagorean
But see,
theorem.
that's the thing. It doesn't say that they're equal, though, does it?
Could you
But
split
45,
that
And you
45
can't
math.
assume it. Right, because this point right here could have been anywhere on this circle, which means that the sides would not necessarily be equal.
I thought you said it was a 45, 45.
No, I never said that. I said it was a right angle. Somebody else said 45. I didn't say that.
It's a right angle.
But my guess is they left some information out. Okay, they probably should have said. Let's see if this works with the answer. Okay, yeah. Let's say this actually.
It's a 45.
Let's see if we get the same answer the book does. Okay, and so I think they're kind of maybe assuming they shouldn't do that, but they're assuming that these two are equal to each other. Yeah, it doesn't say this here at all, though, does it? Yeah, and they should. So anyway, this is 5. If they are equal, then that's 5 squared of 3 or 2. So what is this? So it's 45, 45, right? What is this then? Without doing any calculator work at all.
Is it
Square root of 2 times 11.
25?
It's the leg times the square root of 2, isn't it? So it's 5 square root of 2. What? Times the square root of 2. Square root of 2 times square root of 2 is no. It's just 2. It's just plain old 2. Don't even do the math on that. If you have a square root, right? We've talked about that before. Square root of 2 times square root of 2 is just 2 times 5 is 10. So that whole thing is 10. But what do we care about? The radius. What would the radius be then? The radius would be 5. Okay, now you can actually find the area of the rectangle as well. 1/2 the base times the height, correct? All right, so you find the, and I'm not going to give you the rest. I gave you enough hint on this one. Okay, so now you can find the area of the circle, find the area of the triangle, subtract them. I don't know, you do it. You tell me.
And then you find.
And see if it comes out to the same answer. 55.9. So first of all, what's the area of the circle? It's pi. It's 25 pi, right? So it's 25 pi. So that's the circle. Then the area of the triangle is base times height. So it's this times this, which is 25 times 2, which is 50, right? Take half of that, it's 25. So it's just 25, isn't it? Did I do that right? Okay. So it's that minus this. Well, it's, no. No, you can't. You got to stick it in a calculator because you can't subtract unlike terms. So it's 25 pi. Where's my pi button? Forget. Pi minus 25. 53.5. Okay. Oh yeah, that's. I was looking at my answer. So your answer is 53.5.
Yeah.
Yeah. I don't know.
Assume that, but it doesn't even say
Lack
that.
of communication with the editors and the proofreaders. I mean, there's people that proofread
But
this
you
stuff, and
should
stuff
be
gets
seeing that
through.
anyway, like-
Stuff gets through. I mean, as far as I'm concerned, I mean, I'm looking at that picture that they give us, and I really don't think you can assume any of that stuff. You can't assume that these are equal to each other. Yeah. Yeah, right. They could have said this. They could have put these angles. They could have told you several different things. Yeah, because this could have swung around here like this, and this would have been real short, and you know they could have been real weird angles in here. And I don't think it. Yeah, because the area would be different, wouldn't it? Yeah, if that thing swung around, like, right, if this vertex right here swung around like this, the area would be different, so it wouldn't be the same. All right, I think that's good enough. Let's see.
Yeah.
Okay.
No, you just have to find the batteries.
All right, here it is. It's pages 785, 786. Two sections. The easy section and the more challenging section. Here it is. Yeah, I didn't give you like 40 to 42 or anything, so I just gave you, I gave you 32 to 37, just that little chunk right there. We just did 33. Oh. Well, I mean, turn it in though. You still got to turn it in. Yeah, you got to show all the work. Do all the problems. All right, that's good. Have a good weekend.